To determine whether to reject or not reject the null hypothesis, let's take a look at number 13. We're doing a right tail test. I'm going to sketch the distribution, or normal distribution, and we are told that the critical value is z equals 2.05. So I'm going to mark that on my distribution. It's on the positive side, and it's the right tail. So anything into the tail from that value 2.05 would fall into the critical region or rejection region. Our test statistic is 2.07, which would fall just beyond 2.5 into the tail. So since that test statistic is in the rejection region, we're going to reject the null hypothesis. So the reasoning here is that whatever your null hypothesis is, it's that mu is equal to some value, mu 0. Our test statistic comes from the value of x bar, and it's also affected by the sample size and the standard deviation. But basically it's coming from x bar. So the question is x bar falling far enough away from the mean, the middle there, in order to be able to say that we should reject the null hypothesis, that x bar is sufficiently different from the value in the null hypothesis. And in this case we would say yes, we need to reject the null hypothesis. X bar is falling sufficiently far away. So now let's take a look at number 14. And in number 14, we're doing a two-tail test. And the test statistic is z equals negative 1.55, and the critical values are plus and minus 1.64. So I draw the distribution, and I will mark my critical values. I have one at negative 1.64, one at positive 1.64, and the rejection region is the area into the tail. So again, I'll shade that. You don't really need to shade it, but if you like to, you can do that. And I mark my test statistic, which is at negative 1.55. So I'll say it's about here, negative 1.55. That is not in the rejection region, so I would not reject the null hypothesis. You could say do not reject the null hypothesis. So that's the conclusion we reach for number 14. In number 15, this is basically the same type of problem. The only difference is that instead of being told what kind of test it is, you have to figure that out based on the alternate hypothesis here. So you're told that the alternate hypothesis is that p is not equal to 0.6, so that means that it's a two-tail test, and the critical value should actually be plus or minus 2.33. Doesn't really affect the problem here. But since it's a two-tail test, there's two critical values. And I mark negative 2.33 and positive 2.33. Rejection regions. And test statistic is negative 1.98. So again, do not reject the null hypothesis. Oops. There we go. And then in 16, you have a left tail test. You'll follow the same reasoning, and in that case, you will reject the null hypothesis. So now the only different type of problem you have is 17 and 18, and those are actually easier. You don't need to sketch anything here. So we know that our p-value is 0.37 in number 17, alpha is 0.01. So since the p-value is greater than alpha, we will not reject the null hypothesis. And in 18, let's see, that was 17. 18, p-value is 0.02, which is less than alpha, which is 0.05. So in that case, we would reject the null hypothesis. And that's how you do those problems.